Hi everyone, it's me, Carolyn. And in this video, we are actually going to cover three sections, 1.3, 1.4, and 1.5 for our basic statistics course in chapter one. In the first couple sections, we talked about some of the terminology that goes into statistics itself and looking at just data and how we get data. In this video, we're going to dive more into how do we actually gather the sample from the population that we get. So some of the steps that go into and the terminology and the different methods that we have. So, and 1.3, 1.4, and 1.5 kind of blend nicely together to kind of do all of that in different various ways. So I am going to share my screen. Again, I do have the guided notes attached for you. So you can use them to help take more detailed notes and everything. Keith doesn't switch over very well. So again, we're in chapter one, and we are talking about data collection. And we're going to talk a little bit about sections 1.3, 1.4, and 1.5. Please do be reading the textbook, as they will also go through more detail, some of these things, and maybe show you different examples than I do. So, but 1.3 talks a lot about random sampling. Since we are not actually going to be getting samples ourselves, I don't spend a lot of time going through that, other than to say random sampling means simply that we are randomly going to gather our data. And doing things randomly is very important to make sure that we avoid biases, which we'll talk about later in this video, as much as possible. My cat's going to be a pain. But random sampling is, like I just said, very, very important as to making sure that we get a good sample. One method to help us is something that's called a random number generator. And a lot of calculators have these on them, as well as computers and things like this. And what you can do is kind of just give everyone a number or give everything a number, and then generate randomly using these random number generators the sample itself. So they are very helpful in helping us get those random samples. The other thing that's mentioned in 1.3 that does come into play more so when we get into chapter 5 and start talking about probability is this idea of with replacement or without replacement. With replacement simply is that we will take our subject and then put it back into the pool so it would have a chance of being drawn again. Now, when we do like experiments and things like that, we aren't going to have a person put back in and then given another dose of a drug, so to speak. But when it comes to probabilities, we will talk about that with replacement and without replacement. Without replacement means once you've pulled something, you don't put that back into the pool. So you're not able to get that duplicate showing up. But when we're talking about probability, we can do these things. So for example, you have a bucket of balls. Some of them are red, some of them are yellow. You draw a ball. You either put the ball back in, so with replacement, or you don't, so without replacement. So that's pretty much section 1.3 talks about that random sampling idea. 1.4 takes that sampling idea and talks about how we can actually get our samples, some of the different methods that we do. The first method that they talk about is something called symptomatic sampling. And the way this works is you're going to randomly choose a starting point. So maybe you are standing at the entrance to Walmart and you decide that at 5 o'clock, you are going to randomly start choosing every third person that walks in the door, and you're going to ask them a question. Okay, so this would be a systematic sampling. Or I could stand at my classroom door and ask every fourth person that comes in, or fifth person that comes in. Or if I actually have everyone in the classroom, I could randomly start somewhere and then choose every seventh person or something of that nature. A lot of times this is done in the phone book. They'll take the phone book, which is dying, but they'll take the phone book and they'll start calling every fifth or sixth or 11th person. So that is this systematic sampling. Sometimes that kth number is calculated using a random number generator, or where we start can be found by doing that randomly using a random number generator. Okay, another method is a stratified sample. And a stratified sample will take our population, whatever that happens to be, people or things, and it's going to divide it into groups. And those groups are given the names of strata. And then we're randomly going to choose a sample from each group. Okay. Sometimes those samples from each group will be of the same size. Sometimes they will be different. And we'll talk about that as I give my examples here. So for example, we can talk about the population. Okay. We can divide the population into groups. Let's say we're going to talk about the United States. Well, one nice grouping that's already done for us is the states. We have 50 states. Okay, and we are randomly going to choose a sample from each state. So we could choose 1,000 people in each state and get the data from them. We could choose different sizes based on population, because we might want to make sure to get a better situation of the people where there's more people, so more in California versus Montana. This is kind of done in our electoral methods. So so that's one way to kind of divide groups. Another common way of dividing the human population is by age. So, 18 to 30, 30 to 45-year-olds. A lot of times if you take a survey, you'll see that you are asked that question, which of the age categories do you fall into? So there's another way to get our groups. And then you would randomly choose a sample from each of those groups. Okay, that is a stratified sample method. Cluster sampling is very similar, but slightly different. We start off the same way by dividing everything into groups, but then what we're going to do is we're going to choose a few groups and ask everybody. So if we were talking about dividing everybody by state, we would then pick maybe 7 states and ask everybody in the state. Okay, or ask everybody of a certain age category. Okay, cluster sampling, if you're thinking of Western, we could randomly group everybody by what their 9-10 class is. Okay, so that would be our groups. They're already in these classrooms. Then we could randomly pick a few students from every class that's taking a class at 9-10. Or we could go into a few classrooms and get everybody in that classroom. So that would be a cluster. So the difference between a stratified and a cluster. Here you get random samples from every group. Here you take a few groups and ask everybody. Okay, a convenience sample is something that's easy to do. And we do these sorts of things all of the time. We conveniently send surveys out to everybody in the college. Very easy to do. It's convenient. Sometimes students will do that for classes. You may have to sample things. You'll go to the cafeteria and you'll put samples on the tables and then have a drop box. Very easy to do. Very easy for me to go into one of my classrooms and ask everybody in the class some questions. Easy to do. Okay. You can do multiples of these. You'll notice that all of these do use random sampling, so that's kind of built in. You can do systematic within these stratified. So once you've divided them, you could systematically choose those people from each group. We could get a cluster and systematically choose which clusters we use. We can, in our sample, the one I gave with the systematic, that was a convenience. We were standing at the entrance to Walmart. People were walking in. We chose the every third or fourth one. Again, multi-stage. Okay. The one thing that also goes into all of these is our sample size. That's how many people did we get in our sample. Later on, as we start doing some of the calculations with our data, we will use the letter N to denote that sample size. And how many people we have can greatly affect the outcomes. We like to have larger sample sizes because, as we'll learn later on, nice things happen when we have magic number tends to be over 30. But also we start to smooth out the data by, if we have enough people, we're not going to have those extremes in there. So a sample size is something that you have to pay particular attention to when you are doing your situations. So all your calculations and everything. So we do want to pay attention to that sample size. It is important. Okay, having a sample of size 1 or 2 is not going to be a great thing to try to then say, oh, based on these 2 people, we are going to change everything. So, all right. In section 1.5, it kind of looks at some of the biases that happen when we have these samples. And there are 3 that they talk about. And you have probably heard of some of these before. We hear a lot about the first one, the undercoverage. And that is when one population or portion of the population isn't covered as well as it should be. And that happens all of the time. And there's various reasons for that, whether they are hard to get to, they don't respond, or we just don't try that hard. You know, it happens. So maybe we have, you know, in our coverage, and we have divided everybody by age, and we send out this survey to 30 people in each age category. Maybe we don't get a lot of the younger generation to send back their surveys. Or maybe sometimes we might even have over coverage is another way. You know, maybe we had too many of one portion of the population, whether it be age or race or gender or political views kind of thing. Okay, so that's one. Non-bias, that is when people just don't respond. This one happens all of the time with surveys because surveys are one of the easiest things to do. It's very convenient. It's easy to do, put a survey together, send it out through email. But it is also one that doesn't get answered. Okay, because it is very easy to just hit delete. Or when they used to come in the mail all the time, you would just get that survey and you would just toss it in the garbage. Someone would call you on the phone and ask if they could ask you a couple questions. It was very easy to hang up the phone. So we are getting that non-response bias. What happens a lot of times with surveys, and although surveys are done all of the time, it is also one method because of this non-response bias that does show a lot of bias, the results of surveys, because a lot of times you will have the 2 extremes. You will have those people that have a strong opinion one way or the other that will reply back. So that's why you get those extremes showing up. You also have the people that reply to everything and have, you know, they think their voice is important on every single matter. So we will get that as well. Okay, the last one is a response bias. And this is probably one that we can control a little bit more. And some of the things I have down here that fall under that category are your interview error. So you ask a question, they give you the answer, you don't write the answer down correctly. Okay, So that's one method, one thing that falls under this response bias. Swayed responses. Okay, think about a police officer going into a high school and asking them if they've ever drank alcohol. Well, considering at the high school level, I believe it's still illegal to drink underage, and being asked by a police officer, you are going to be swayed one way or another to answer that question a certain way. A little bit harder to get truth responses on some of these things when you have a swayed response. The way a question is stated can be very misleading or very misdirecting a person to answer a certain direction. You know, how do you feel about killing babies? I hate to bring up the abortion thing, but that if I just say killing babies, well, no one wants to kill babies. That just sounds very strong. But when you start asking it in different methods, different ways, you're going to possibly get a better response, a more truthful response to the types of questions that you want. So making sure that your questions aren't too strong, too harsh, too guided can be very important. Also, data entry error. So if you have someone with all the ones and zeros and just numbers and they're entering the data, again, those things cause biases. So when we have errors, they always can sway data to look one way or another. So in this sections, we have, I'm going to stop sharing here. We have started talking about how we get our data. So the different methods of getting samples and some of the biases that go into them. In our last section of the chapter, which is 1.6, we're going to talk about design experiments. Again, there are many, many ways to design experiments, and we're just going to touch on a few of those. So I will look forward to seeing you in the next video, or kind of seeing you in the next video. But again, if you have any questions, feel free to email me. I'm out there. So talk to you guys all later.